Good morning. Today we'll be discussing about the complex plane, the Argand diagram, and different forms of complex numbers such as coordinate representation, modulus argument form, and exponential form. Okay, so let's go for a complex plane. A complex plane. Complex plane. Normally we represent a real number on a number line. So if you want to represent a real number, there we use a number line which we learned in primary classes. Suppose you want to represent a number 3, we use a number line to represent that particular number. But when we want to represent a complex number, we know that a complex number is in the form of z is equal to x plus iy. And when we consider this complex number, we can say it has two dimensions. So a complex number has two dimensions while a real number has only one dimension. That is why we can represent a real number on a number line. But when we consider a complex number, it has two dimensions because a complex number is the union of a real number and imaginary number. So here this complex number has two dimensions, which are a real number and an imaginary number. Okay, so as a complex number has two dimensions, complex number cannot be marked on a number line. Then where do we mark a complex number? Yes, it can be marked on a plane, because we know that two-dimensional figures are represented on a plane surface, isn't it? So as complex number has two dimensions, we have to represent every complex number on a plane surface. For that, Jean Robert Argand, mathematician Jean Robert Argand, created a method for what? To represent the complex numbers on a plane surface in the form of Argand diagram. So what is Argand diagram? Argand diagram is a diagrammatic representation of complex number in coordinate system. So for that, consider the coordinate system. What we have to do? We have to consider the coordinate system. Coordinate system. You know what is coordinate system? Yes, coordinate system consists of a horizontal line known as x-axis, a vertical line known as y-axis. They both intersect at a point O known as origin. The x-axis and y-axis divides the plane into 4 quadrants. Yes, and the right side of origin gives the positive values, the left side of origin gives the negative values. Top of origin makes positive values and below origin gives us negative values. So these all informations come under coordinate system. Okay, but when Argand described this diagram was of course made up in coordinate system, but in a different format, in a format that the horizontal line is not x-axis. The horizontal axis is called the real axis, where the real number appears. Okay, so we can represent it as real axis of the complex number. Because remember, every complex number is the union of a real number and an imaginary number. So horizontal axis is real axis. So you can guess what will be the vertical axis. Yes, it is known as imaginary axis. So real axis and imaginary axis. Okay, now let's name it. One, let's calibrate it. So in this coordinate system, horizontal is real and vertical is imaginary, and I marked a point A which is in quadrant 1. Okay, and when you look at this point A, you can find the real value as 2 and the imaginary value is also 2. So the complex number A can be written as 2 plus 2i. When you consider the point B, the x value is 4 and the y value is 3, and you know every complex number is in the form of x plus iy. So this complex number can be written as 4 plus 3i. 4 plus 3i, because the real value is 4 and the imaginary value is 3. And at that same time, let's connect the same with the position vector. If you join the origin to this point, then we call OB as the position vector. So we call OB as the position vector with coordinates 4 and 3. Yes, let's mark another one point. C. When you consider C, you can identify the x is minus 2 and y is 3. So C can be written as minus 2 plus 3i with position vector OC is equal to minus 2, 3. Okay, and now suppose your question is to represent z is equal to minus 2i minus 2 minus 3i on the plane. Suppose your question is to represent minus 2 minus 3i on the plane. So here you have to identify the corresponding x coordinate and y coordinate. So it is in the form of x plus iy. So tell me, what is the x coordinate? X is minus 2 and iy is same as minus 3i. That means y is minus 3. So the ordered pair is minus 2 minus 3 can be marked as x minus 2 and y minus 3. That will be the point representing minus 2 minus 3, so that this will be the position vector in the form of minus 2 minus 3, the form of a column vector. Okay, so this is a basic fact of representing a complex number in Argand plane or complex plane. This plane is considered as complex plane. Okay, and usually a complex number is denoted in the form of z is equal to x plus iy, where z is the real part and iy is the imaginary part. Okay, and x and y are real values. Though iy is the imaginary part, y will be a real number. Okay, we call this form of representation like z is equal to x plus iy as the Cartesian form. The Cartesian form. This form is considered as the Cartesian form because it consists of the Cartesian coordinates x and y. So this form is considered as the Cartesian form. And as we know it as a Cartesian form, the point is x, y. So if you represent this point in a Cartesian, a complex plane, like this is real z and this is imaginary z, and suppose this is a point xy. We can say that this line represents the position vector. If the point is A, OA is the position vector. Okay, in the form of x, y. Okay, once we know the position vector as column vector xy, that is z is xy, we can find the magnitude of this. Magnitude of z. Remember the magnitude of a vector. We learned it in IGCSE classes. So magnitude of z can be represented with mod z is equal to under the root x squared plus y squared. So magnitude of z can be found using the formula square root of x squared plus y squared, which is nothing but this length of OA. That is magnitude of z. Okay, is it clear? Okay, then if z is equal to 2 plus 3i, then what is magnitude of z? No doubt it is under the root 2 squared plus 3 squared, which is under the root 13. If z1 is 3 minus 4i, then what is magnitude of z1? Yes, it is root of 3 squared plus minus 4 the whole square, which is square root of 9 plus minus 4 square is 16. So we get it as under the root 25, which is equal to 5. So this is the way we do calculate the magnitude of a vector. vector, at that same time magnitude of z, magnitude of the complex number z is equal to x plus iy, can be calculated by mod z is equal to root of x squared plus y squared. Okay, is it clear? Okay, once we know about magnitude, the next term we know is argument. Argument of a complex number. So what is argument of a complex number? It is nothing but the direction of the position vector. You know, when we compare a complex number with a vertex, with a vector, it has both magnitude and direction. A vector has both magnitude and direction. Magnitude and direction. So now we already learned about the magnitude. Now direction. Okay. So direction of a vector is defined using a term known as argument. So argument is the direction of the position vector. The argument of a complex number is the direction of the position vector. Means whether the position vector is in the positive direction or is it in the, these both are positive directions, is it in the negative direction? So what is the direction of the position vector? That is described by a term known as argument. In a more simplified way, if you say an argument is an angle. See, with the help of angle we can find the direction. We will discuss how to find that. It is an angle between the positive real axis and the position vector. So it is an angle between the positive real axis and the position vector. So think once again, argument is commonly a term which used to describe the direction of a position vector in complex number system, in complex plane. In complex plane, to describe the direction of a position vector, we use a term known as argument. It can be described as an angle. So argument is an angle between the positive real axis and the position vector. It's an angle between the positive real axis and the position vector. Okay, let's see what do you mean by this. So this is a real axis, this is imaginary axis. Like suppose you have a point A here, so that this is the position vector. Now an angle between the positive real axis, remember positive real axis, which is the positive real axis? Yes, this one, because this is the positive side and this is the negative side, because it is plus 1, plus 2, plus 3, plus 4, negative 1, negative 2, negative 3, negative 4, etc. So an angle between positive real axis and a position vector is considered as an argument. Okay, if we consider another one, now here, which is the argument? Is it argument? Is it argument? No, because this is an angle between negative real axis and position vector. Our question is, our term is not negative real number. We want positive real number. So which is that? This angle is the argument. So this is the angle between positive real number and position vector. So just think that you start your angle from positive real axis. Start from positive real axis to position vector. Okay, always let it be clockwise direction or anti-clockwise direction. If it is anti-clockwise direction, that means what you can see in these two examples. These two examples shows the anti-clockwise direction, because from positive real number to the position vector, see the direction. See the direction here also. Yes. So both makes anti-clockwise direction. That means here the argument denoted by theta is positive. So when the argument is positive, these all things we have to think. The argument is positive with the anti-clockwise direction from the positive real axis to the position vector. Okay, so in this case, look at this. When you look at the first angle, it is an acute angle. It is okay, directly we can use. Directly we will get the answer for that. And to find this angle, purely we use trigonometry, that too tangent. We use the tangent of trigonometry. Okay, now when you look at this second figure, here the argument is an obtuse angle. First thing is, it is an obtuse angle. Argument is obtuse. That means argument means theta is obtuse. It is in anti-clockwise direction. That means it is positive. Anti-clockwise direction means it is positive. And it is in second quadrant. Okay, so to find this, what shall we do? So to find this angle, what we do is, we will discuss how to find this angle. Okay, in detailed way we will discuss how to find the angle. To find this angle theta, what we do is, we will find this acute angle. Let's name it as alpha. Just for our convenience, we are making a name. Okay. Okay. So when we want to find theta as it is obtuse, we are going to find this alpha, this acute angle. So remember, the same thing we have discussed in trigonometry also, but there it was different, here also different. There is no connection between both of these. Now you can understand theta can be found by the total 180 minus alpha. So theta can be found using the straight angle 180 degree minus alpha. So here now at this moment you have to remember another one thing, which is the argument to be represented in radian. The argument should be represented in radian measure. That means we cannot use 180 degree here. So instead of that, you have to use it as pi radian minus alpha. So we get theta as pi radian minus alpha. That means theta is pi minus alpha in this question. Here theta is directly we can find out. Okay. So is it clear with first quadrant and second quadrant? Yes. Now let's go for the third quadrant. Suppose your position vector is here. This is your position vector. Now usually which angle we consider? Normally we consider this angle now, because as we want the positive angle, usually we consider this angle. Yes, but it is wrong, because here we get a new concept, which is the argument. Theta has a range which is between minus pi and up to pi. It can go maximum pi, that means maximum 180, because now you see this angle, this is more than 180. This angle represents more than 180 degree. So can we use this angle? No, we cannot use this. So which will be the correct angle here? Yes, this one. Okay, so remember this one. The argument lies between minus pi and up to pi. Okay, so the values between minus pi to pi is called the principal argument. What is that? Principal argument. So principal argument can take the value only up to pi. If it is beyond pi, we have to find out some other method, some other way, like this question. In this question, our argument is more than 180, because up to here it is 180. So it is 180 plus some, as it is in third quadrant. So when you look at this picture, when you look at this diagram, which will be the possible argument here? Yes, this one. This will be the possible argument. So here what are the things to be noted down? One thing is position vector. Position vector is in third quadrant. With that you can understand both the coordinates are negative. Second thing, the argument theta is in clockwise direction. See, it is in clockwise direction. That means theta is negative. That means the theta we find to be changed to a negative value. Okay, so do we need to think anything more about this? No. So this is about the third quadrant. And when we go for the fourth quadrant, suppose position vector is in fourth quadrant. Now argument can start in this way or this way also, which is the correct way here. If you go in anti-clockwise direction, it is more than pi, more than 180 degree. So that is wrong as per our principal argument. Remember, principal argument is between, sorry, not less than or equals, less than, is between minus pi and up to pi, pi also included. Okay, so this way of representation is wrong here because it goes beyond pi. So which is the correct representation can be used here? Yes, this one. That will be theta. So here also think theta is in the quadrant 4, or position vector is in the quadrant 4, and theta is in clockwise direction. That means theta is negative. Okay, so let's remember all these things once again. The position vector can be in first quadrant, it can be in second quadrant, it may be in third quadrant, or maybe in fourth quadrant. So in first case, the argument is this, which is theta, which is in anti-clockwise direction. So here theta is positive. So when you consider the second figure, here position vector is in second quadrant. That means this is theta, and here theta is in anti-clockwise direction. So theta is positive. Here also theta is positive. And for finding the value of theta, we make use of this acute angle alpha. What we do is pi minus alpha to be done. When you consider the third figure, our position vector is in quadrant 3. So to find the argument, we have to use this clockwise direction, as our theta has a limitation which is between minus pi and up to pi. Okay, so here you can understand theta is in quadrant 3 and it is in clockwise direction, so it is negative. And to find theta here, what we do is we find this angle, which is alpha. Now this total is 180. In that case, you don't think about this is negative or positive. This total angle is, however, it is a straight angle 180. So from 180, remove alpha, delete alpha. So from pi, delete alpha. Same concept. But the difference is, as theta is negative, it becomes negative of pi minus alpha. Once again, here how do we find theta? Here this is theta, and theta is in clockwise direction, so it is negative. Now to find this theta, we have to identify this angle alpha. So when you take the sum of theta and alpha, it is 180 degree, or theta can be found by 180 or pi minus alpha. This is the numerical calculation, the numerical value. But when you think about theta, it is negative. So final answer should be negative of pi minus alpha. Okay. And when we come to the fourth case, here what do you identify? The position vector is in quadrant 4. So the argument is in clockwise direction. That means theta is negative. Theta is negative, and here also theta is acute. Theta is acute. So remember, theta is acute in two quadrants. Which are the two quadrants? Q1 and Q4. But what is the difference? In Q1 theta is positive, but in Q4 theta is negative. And theta is obtuse in two quadrants. Which are they? Q3 and Q4. Sorry, Q2 and Q3. Q2 and Q3. So what's the difference? In Q2 theta is positive, which is pi minus alpha, and in Q3 theta is negative, which is minus of pi minus alpha. Got it? Now let's go for a few questions related to this. Question: find the modulus and the argument of z is equal to 5 plus 12i. So whenever we do like these questions, we have to draw a simple diagram. It is must to draw a simple diagram. Okay, so draw a simple diagram which has real z, imaginary z. Now as it is z is equal to 5 plus 12i, you know, if you take xy, ordered pair xy, it is 5, 12. Yes, x is 5 and y is 12 because it is in the form of x plus iy. So x is 5 and y is 12, and you can understand both are positive, so it is in quadrant 1. Okay, so let this be that point. Okay, now when you think about the position vector, this is the position vector. Now it's very important, we have to complete a right triangle. That means from this point draw a perpendicular line. Draw a perpendicular line. So this is a vertical length. Vertical length is known as the length of y-axis. That means this length is 12 and this length is 5. 5 and 12. X-axis length is 5 and y-axis length is 12. Okay, so the first thing what we need to find is nothing but what we have to find: modulus or magnitude. So magnitude of z or modulus of z is equal to root of x squared plus y squared. It's very simple, which is root of 5 squared plus 12 squared, which is equal to under the root 169, which is 13. That means this is the length. This length is now 13. Okay, now we are going to find the argument, and argument of z can be written as argument arg z. This is enough. Okay, so now we are going to find the argument. So let me make this figure a little more good. This is 12 and this length is 5, and this is known as argument theta. Okay, so before finding the argument, you have to be very aware that theta is acute. So here argument of z theta is acute, it is in quadrant 1. That means theta is positive. So these are all things we have to clear. Now when we think about this theta, 12 is the opposite side of theta and 5 is the adjacent side of theta. So from theta, 12 is the opposite side and 5 is the adjacent side. So we can use trigonometrical ratio tan, or tan theta is equal to 12 divided by 5. So what is tangent ratio? Tangent ratio is opposite side divided by adjacent side. Yes. So from this we get theta as tan inverse 12 over 5. Is it? Which is equal to 1.18 radian. Make sure your calculator is in radian measure. Okay, the mode should be radian. Okay, so this is one question. Let's go for another one. Second question. Here z is equal to -3 plus 4i. Question is same, find the magnitude, that means modulus and argument. For that, let's draw the rough diagram. So here x is -3, x is -3 and y is 4. So x is negative and y is positive. It is in which quadrant? X negative, y positive, x negative, y positive. It is in quadrant number 2 now. Yes. So it is in quadrant number 2, the point. So that this is the position vector and this is your argument theta. So before going to the argument, let's find the modulus. So modulus of z is square root of -3 squared plus 4 squared, which is square root of 25, that's equal to 5. That means this position vector length OA, which is same as length of OA. This is not necessary to write, just to show you I have written. Okay, now to find the argument of z. Now we are going to find argument of z. For that you have to complete the right angled triangle with OA. With OA, how do you complete the right angled triangle? Only the option is draw the vertical line. Got it? Okay, now tell me what is the length of this vertical length. What is this vertical length? This is y now. What is y? Y is 4. What is this horizontal length? X is -3, but this horizontal length is 3. Length is a quantity, it never be negative. This negative, x is -3. This negative is to represent the direction as left side. Other than that, the length of the line is just 3. Okay, so take always the positive value. Now let's find this angle. Remember, argument of z, it is in second quadrant, position vector is in quadrant 2. So theta is obtuse and it is in anti-clockwise direction, so it is positive. Therefore theta can be found using pi minus alpha, where what is alpha? This one. So you have to remember that. So here alpha can be found using opposite side divided by adjacent side. Opposite side divided by adjacent side. So we get tan alpha is equal to 4 by 3, or alpha is equal to tan inverse 4 by 3, which is equal to tan inverse 4 by 3. Okay, let it be tan inverse 4 by 3. So we are going to find out theta. So theta is total pi minus alpha. From total pi, delete alpha, we get theta. So we get it as pi minus tan inverse 4 by 3. Do this calculation, we get it as 2.21 radian as answer. Okay, shall we go for another one? Because we need to discuss all the 4 types. Okay, so question number 3, z is equal to 12 minus 5i. Let's find the modulus. For modulus, the figure is not required for us. We can find the modulus directly, which is under the root 12 square plus minus 5 square. That is square root of 144 plus 25, 169, which is equal to 13. We got the modulus. Now to find the argument of z, let's make the figure. X is 12 and y is minus 5. X is 12 and y is minus 5. That means x is positive and y is negative. Which quadrant? Is fourth quadrant. Okay, so which is the argument here? Yes, this one is theta. And remember, theta is in quadrant 4. It is in clockwise direction, so it is negative. Okay, so even that you can mention in your answer. You can write here theta is in quadrant 4 and is negative. You can write this much. This is enough for every answer. Okay, so to find this angle, what shall we do? Yes, the normal method. We complete the right triangle so that this length is 12 and this length is 5. This 5. It's not minus 5. Why should be 5? So theta is tan inverse. How do you get theta as tan inverse? How do you get theta as tan inverse? We can do that one directly, okay, because you know here we have to use tan theta is 5 by 12 or theta is tan inverse 5 by 12. That you can use directly. You no need of doing tan theta always. We can find directly. So here theta is tan inverse 5 over 12. Is this the final answer? No, because theta is negative. So theta is nothing but negative of tan inverse 5 by 12. We get it as minus 0.395. That's answer. Okay. Question number 4. Z is minus 4 minus 3i. Okay, so here let's find mod z. Mod z is square root of minus 4 squared plus minus 3 squared. Calculate it, we get the answer as 5. Now to make the argument, here x is negative 4, y is also negative 4, both are, y is negative 3, sorry, y is negative 3, both are negative, that means it is in third quadrant. Okay, the point is in third quadrant. As it is in third quadrant, so here theta is in quadrant number 3, so theta is negative. And you know how do you find the theta? Theta can be found by pi minus alpha, as it is obtuse angle, and as it is negative, minus of pi minus alpha. Okay, this is not necessary to write, this one we can identify. Okay, we can find out that one. No need of writing, these two is enough. Now to find this angle, we have to complete a triangle here. That means we have to find out this angle first, alpha. With what is this length? It is y3, x 4. So this angle alpha can be found by tan inverse 3 by 4. See, remember there is no negative or positive for alpha, just you find alpha. Okay, so you got alpha here. Now we are going to find theta. You know theta is normally, this total is pi minus alpha. Total is pi minus alpha, we get theta. Yes, but now you think about theta. Theta is positive or negative? It's negative, so you have to put a negative here. So we get it as minus of pi minus alpha is tan inverse 3 by 4. Just do this calculation, we get an answer which is minus 2.50 radian. This answer. Okay, make sure you are writing the answer in 3 significant figures. It is compulsory. Okay, now just you do a few questions like find modulus and argument. Z1 is minus 7 plus 5i. Question number 1. Z2 is 1 plus I. In 1 plus I, what is y value? Is 1. 1 plus I means 1 plus 1i. Z3 1 plus 5i. Z4 minus 7 minus I. Z5 5 minus 2i. Z6 5i. That means what is the value of x? Let's think. Z7 8 plus 15i. Z8 minus 12 plus 5i. Z9 60 minus 11i. And Z10 root 5 plus 2i. Thank you.